And bam, here we are. We have come to the base of the Mission Valley Formation, at least right here. Now you might notice, wait a minute, let's take a look at this contact. One, this is not Stadium Conglomerate here. This is Santiago Peak Volcanic. So that tells us something already. Let's take a closer look at this rock here. Don't take my word, it's volcanic. One, you can see this interlocking crystals. But you look at this, you see interlocking crystals with interlocking crystals. Here you see something kind of dark, maybe a basalt-like thing. But you see lots of angular shards and fragments. This is no ordinary lava flow. This is a volcanic, trigger alert, I'm about to yell, a volcanic breccia! This was a violent eruption. The Santiago Peak volcanics were part of a subduction zone with a lot of volatile material, water, carbon dioxide in them, that when brought to the surface expanded rapidly, literally pulverizing the solid portion of the magma as it rose and creating a lava flow of lots of hot flying bits of material, lahars, mud. Where was this volcano? We don't know. It's been eroded. It's been buried. And again, what we're looking at is the eroded remnants of some of the lava flows of this volcano. Not only that, they were not eroded perfectly horizontally, they were eroded in a rough, irregular fashion. At one point in history, this whole region, I'm guessing about 50-something million years ago, would have been a gently undulating plain. There might have been quite a bit of soil here. In fact, just on the other side of the ridge, we do see some substantial soils from 50-something million years ago. We see a couple of these also up in North County as well. These are all known, these, plus the caliche layer we see at the top of the Mission Valley Formation are all examples of paleosols, ancient soils that formed in a very different regime and often got buried by sometimes, if not often, got buried by subsequent sedimentary deposition. So again, this is your textbook unconformity here. We actually have two in this picture. We have one at the bottom of the hill, right here, and then one at the top. But this one below here is a lot more, the contact has a substantial slope to it, whereas the rocks have much less slope. That's one of the big giveaways that you have an unconformity. Two, you have an igneous unit in contact with a sedimentary unit. Now, sometimes you can get an igneous unit in contact with a sedimentary unit, and the igneous unit is younger. That would be if you had either the igneous unit cuts across the sediments, like you see down at Scripps Beach, where a dike cuts through what I think's the Scripps Formation or Torrey Sandstone, one of the two. You also, the other sign that the lava flow is younger is if there is metamorphism of the sediments. In Santa Cruz, there are granites and marbles, and the marbles have been clearly altered by the cooking by the granites. Here, however, you saw that the Mission Valley sandstone did not appear altered whatsoever. And you saw a soil, evidence of a soil erosion. Just to show a little bit more, there's quite a number of pits on here. These pits are the less resistant minerals, the ones that dissolve more readily, being ground away in what was a substantially warmer and wetter climate. There's probably quite a thick soil here. We know that this region 50-something million years ago was kind of almost a jungle and located very near the equator. Most of that soil is formed of loose clays that in the intervening millions of years have eroded away. We still have some preserved on the other side of the mountain over there, but these pits are a dead giveaway that this has eroded. The current climate does not create pits of chemical weathering anywhere near as intense as this. Only an acid, organic, rich soil that you'd find in a tropical forest could create these many chemically weathered pits in your rock. I just also like to point out that you have these fractures running through this volcanic that are parallel to the river course. There might, not going to say how related one is to the other, but it's entirely possible that something happened there. So that's it. Yeah, we have an unconformity, and we're going to be sort of walking along the edge of this all the way down for a while. This is going to be our last real stop for a short bit, because you're going to continue to see Mission Valley Formation for a while. When we get to the stadium, I will let you know, and we'll do another little stop there to mark that contact. And also, one of your goals is going to be to sort of try to fill in a little rough geologic map of this area, and tell me what you see here. So, and try to tell a little story of the history based on these little facts, and recognize the relative dating relationships present here. We're also going to show you some outcrops from up the river, where we have the granites directly in contact with the Santiago Peak volcanics, to help you ascertain which one of these is older. And again, the Santiago Peak volcanics are probably also what's across the river here, so we're all on one continuous lava flow. Intriguingly, I know hiking right there on that mesa across the river valley, the Rancho Mission Canyon Trail, they call it, that over there you're seeing mostly sedimentary rocks. So there was probably already an existing low between here and the peaks of Del Cerro by the time a lot of these rocks were laid down, perhaps related to these vertical fractures in the volcanic rock.